Hello, welcome to this class, Smart Core Academy. Uh, Before we dive into today's lesson, subscribe below the video. Give me a thumb if you find this useful in your uh, life. You also comment in case if there is any clarification or anything that you may need us to take you through. To come back to our class for today, we're still under thermal expansion, where we have looked at linear and area. But for today's lesson, we are going to look at volume expansivity. Volume expansivity. This is where now an object increases in volume compared to area expansion, where there is only an increase in what? In area, compared to linear expansion, where there is an increase in the length of an object. So here, volume expansion simply means an increase in volume per unit volume per degree rise in temperature. So volume expansion is represented with a Greek letter that is gamma. This is a Greek letter for representing volume expansion. Mathematically, we say that volume expansion is equals to change in volume per unit volume, which is the original volume, multiplied by change in temperature. Change in temperature. We can write it like this: volume expansion, which is represented with Greek letter alpha gamma s being equals to change in volume. Change in volume is written as letter V all over the original volume. The original volume here is the initial volume, which is V1 multiplied by change in temperature. Our change in temperature is what? Delta T. You can also break it down by writing gamma as being equals to V2 minus V1, because change in volume is final volume multiplied, subtract from initial volume. Then we're going to have volume 1 into T2 minus T1. That is how we break down the equation or the formula for volume expansion or cubic expansivity. Here, the SI unit of volume expansion is what? Is per Kelvin. SI unit is per Kelvin. We get per Kelvin from, this is centimeters cube, this is centimeters cube. This one here is Kelvin. You cancel centimeters cube and centimeters cube, you are going to remain with 1 all over K. 1 all over K is also right in inverse form, and you put a negative 1 on top of what? On top of K. This is where we came up with per Kelvin. Volume expansivity or cubic expansion is also related to linear expansion. How? Gamma is 3 times alpha. That is the relationship of volume expansion and linear expansivity. We are going to look at examples and we see on how to solve problems under volume expansivity. This is an example under volume expansion. Says that the increase in volume of 10 centimeters cube of mercury when the temperature rises by 100 degrees Celsius is 0.182 centimeters cube. What is the cubic expansivity? Here we are going to say solution and we give down the given parameters. Say solution given. Say that the increase in volume of, that means this is our initial volume. The increase of volume of 10. Say volume 1 is equals to 10 centimeters cube of mercury when heated, when the temperature rises by 100 degrees Celsius. There is something we need to understand from this statement. When the temperature rises by 100 degrees Celsius, this one here is never an initial temperature and it is never the final temperature. but it is a change in temperature. For instance, we have 2 as temperature 1 and we have uh, 5 as temperature 2. When we see here this initial temperature, as it has rises to 5, which means it has taken what? 3. We will say that this one has increased by 3. So this one is going to be our change in temperature. That is delta T has been equals to 100 degrees Celsius. We convert it to standard unit of temperature. We add it by 273, where we are going to get 373 Kelvin. By 1000 is 0.182. This 0.182 here, the initial volume is 10 centimeters cube. But when you read it, when the temperature rises by this is 0.182. That means this is our change in what? Our change in volume. It is never what? A final volume. Why? Because a final volume can never also be less than what? The initial volume. This is the change of the two volumes. Therefore, we're going to say change in volume as V equals to 0.182. That is centimeters cube. What is the cubic expansivity? Don't get surprised when you see cubic expansivity. Cubic expansivity also means volume expansivity or volume expansion. So now let's say the cubic expansivity, which is gamma, as B equals to question mark. But recall the formula. We say that gamma is equals to change in volume all over V1 into change in temperature. Here we substitute the values of all those uh, terms. Where change in volume, when we look around at what our parameters here, change in volume is 0.182. We are going to put it there, 0.182, all over the initial volume of volume 1. Now parameters, initial volume is 10 centimeters cube. We are going to put 10 centimeters cube. We multiply by the change in temperature. Change in temperature is 373 what? Kelvin. 373 Kelvin. Here we are going to multiply this time with this. Then after that one, we divide it by our uh, change in volume. Let's say gamma is equals to, we maintain the numerator 0.182. Let's press in our calculator. We say we have 10 times 373. Here we will get 3000. We say gamma as B equals to 0.182 all over 3070. Here we will divide this by this. Let's say 0.182 by 3730. Here we'll get gamma SB equals to 4.88 times 10 raised to power negative 5. And SI unit is what? Per Kelvin. This is the end of this example. For more, we are going to look at example 2, whether we get satisfied with this topic. This is our example 2 under volume expansion. So that given the linear expansion of a metal 0.00267 per Kelvin, what is A, area expansion, then B, volume expansivity. Here we are given the linear expansivity, but we are asked to find area expansivity and volume expansivity. Now let's say solution. Say given we have the linear expansivity, which is alpha as 0.00026 per Kelvin. Question 1. What is area expansivity? Here, in our last class, we say that area expansivity is related to linear expansivity, whereas beta is equals to 2 times alpha. If you do not come across that one, I'll drop a link in the description of this video, say that you also go and check on how area expansivity is related to linear expansivity. Here we are given the alpha, but we say that recall, say that beta is equals to 2 times alpha. That is the relationship between area expansivity and what? And the linear expansivity. Let's continue. Beta is equals to 2 times. The value of linear expansion is 0.0000267. Then this is where we get our alpha. Say that beta will be equals to 2 times 0.00267. Then we'll get 5.34 times 10 raised to power negative 4. SI unit is per Kelvin. This is part A. Part B, what is volume expansivity? We are also looking at the relationship on how this volume expansivity is related to linear expansivity. Let's say part B. Part B, we are asked to find volume expansivity, which is gamma. And gamma is related to linear expansivity 3 times alpha. Here we are going to say gamma has been equals to 3 times 0.000267. You multiply 2 times 0.0000267, you will get is 3. Let's say 3 times 0.000267. We are going to get 8. I'm going to get 8.01 times 10 raised to power negative 4 per Kelvin. This is the relationship of volume expansivity and linear expansivity. Our part A is the relationship of beta or the volume area expansivity and the linear expansivity. Also here, I'm going to leave a work that you will do. You will prove on how beta is equals to 2 alpha. Another one is gamma has been equals to 3 alpha. Does it really mean that the three of the thermal expansivity are related? If they are related, put it in the comment section. Drive for me those equations and I will come and check. We have come to the end of this topic. If there is any concern, you may drop in the comment section, clarification, or anything that may need us to take you through. Smart Core Academy giving you online science courses. Subscribe. Don't forget to give me a thumb. Thanks.